Good morning, everyone. I think we can start. I hope that the microphone works okay today as well. Seems that yesterday went well. Let's see today. Um, Yesterday we finished with an exercise that today we will solve. The exercise is here. I will share the share pad. So if you go at the end of that document, you will find the exercise that we will solve today. Um, let me share my application. Is RStudio allowed? So homework from today was to use the last thing that we saw were factors that were useful for categorical data, and we will use them in our surveys data frame. Because I open RStudio, and as you can see, the environment is empty, memory is empty. So I needed to start from the beginning in terms of I need to load the libraries, load the data frame, and I can start working from that. So this also will be like a we will remember some contents from yesterday. Okay, so first thing is we need to load the library tidyverse. So library loaded. Another thing that we will do is to import load the surveys. That if I go back, I may find. Yeah, here is the line that we want to copy and paste. So now we can find in our environment that the service has been loaded. And now I can start with the exercise. We can change the columns. The first thing is change the columns taxa and genus in the service data frame into a factor. So we can have a look how we did yesterday. Yesterday we did that for surveys sex, so we can repeat that as well. And we can also do, we need to do this for the columns taxa and genus. So let's do that. So it's surveys. Dollar, remember that is to select the column. And in RStudio, when we type dollar, we can see the columns of the. So we will select taxa here. So we need to the designation symbol that is an arrow that we can write this with the alt minus, and now the function factor, and again the name of the column surveys dollar taxa. We execute that, and the same with the genus factor surveys genus. And also they said that using the functions you learned before, yesterday, find out how many rabbits were observed and how many different genera are in the genus column. So I think one of the functions that told us that was summary of surveys. So the questions are how many rabbits are observed. So here, for instance, in taxa, we get the amount of, for each animal, we get the count. So for the rabbit, will be 75. Also, how many different genera are in the genus column? Okay. Yeah, the way of because here we see in genus, so we see all of these genera, but we don't have the count of. If you remember, there were a function that was called n levels that told us the number of levels that we have in this factor. So if we execute that with surveys genus, we get that we have 26 different genera. Also, if we want to know all of them, I think was levels. Let me check if that's okay. And here you see the 26 different genera that we have. So this is regarding the yesterday's exercise. Let me check if something is okay. Was a part that was not mentioned about the levels. Sorry, the factors that we can, if we want, we can plot the factors. So, for instance, using the function plot, we can plot a surveys $sex. We can see here in this on the right down part of the window, we can see the plot of the factor, the surveys, sorry, the sex factor. Not sure what I didn't ask. Do you have any questions regarding this exercise? If you have any questions, please feel free to write them in the chat or. Okay, there is a question that is, can I include the NA to the plot? Yes, I think it's possible. Actually, this is what we will see later. The thing is, because we don't, when we plot NA is like discarded, but we can say that we want to have a NA in our. So the way of doing that is we would need to add what we will do in order not to modify the surveys. We will do a copy of surveys here, and we will save in a variable called sex. So if we do that, and also we do str sex, we can see that we have a factor with two levels. That could be 2, 2, and A. But when we plot that, this is discarded because as you see, there are two levels, and these are the levels that are print female and male, but NA are not considered as a level. But we can do that. we can, if the function is, we need to write a sex segment as well, and then add NA sex. So if we do that and we write again str sex, we will see that we have now a factor with 3 levels rather than 2. We have F, we have M, and also we have NA. So we need to use this function to do that. And now if we plot that sex, we see that we have a female, male, and NA that here that doesn't appear anything. But also we can modify that. How to modify that? The way is if we print levels, we have F, M, and AA, but we can modify levels. We can say the position 3 will be undetermined, or NA, or anything that you want. So if you execute that and now you plot again, you see that now appears undetermined. So that is well, there are like 2 small exercises, but that I think that we can do together in order to make some progress. The exercise is we have rename the third one, so rename the first and second one and put female and male. So the way of doing that is writing levels, sex, and the position 1, that is a female, so we write female, and the same with male. And also the exercise said that we can, if we want to change the order, as you remember yesterday, it was possible to change the order if we do the following. Sex, male is creating another factor using sex, and now we specify the levels. Levels are a vector or undetermined, female, and male. So now if we do plot, we find that undetermined is at the beginning, and then female, and then male. This is a very basic plot, but later today we will see how to create better ones. But this is just to, in order to, if we just want an easy plot, or just to visualize some results very quick, we can use the function plot like this. Okay, so let me check. One thing that we'll see today as well is regarding how to work with the date, because yesterday, if we print, we can do summary surveys, or maybe rather than summary, we will do head. Let's see if that works. You see here that we have 3 columns with the date: month, day, and year. If we want, we can combine these combine this and create a new column, for instance, with the with a date, like choosing, I don't know if we want to use day, month, year, or we can do year, month, day. So we can choose whatever we want for our data frame. So first of all, we need to load. There is a library that is called library date that we will need to load it in order to use it. Okay, we'll make this. Okay, it's loaded. And the thing with that library is we can get the columns month, day, and year, and we can create the the date that or the format of the data that we want. It is good that this is saved in 3 different columns, and we have because with that we can play around. We can choose the format that we want. So that is well, we can create. I will tell you some functions that this library has. We can have a variable that will be called my date. That is well, we have the arrow, and there is a function that is called year, month, day, YMD. And well, as you can see in on the help, is a parse dates with year, month, and day components. So we can write today's date, for instance. Can write 2022 07, today's 20. And now you see that we have in our memory, we have this value, my date. And now I can str my date and tell us that in this case, this object, variable object, is from the class date, and the format is this one, a year, month, and day. Well, this is like one of the functions. There is another way to do that. That is using when we have the date separated, we can use the command paste. So we can do again in my date, we can reuse this object. Can use this function, and what we will use is the command paste. Paste. You need to specify the things that you want to paste. So it will be the year 2022, the month 07, and the day that is 20. And once that you have written all of the things that you want, let's say, to paste together, you need to specify the separator. That will be a minus hyphen. So if we execute that, and we execute again str my date, you see that we have the same result. So as you can imagine now, what we will do is we will use this function paste to generate a new column called date in our survey. So let's go step by step. We can copy this function here, and for year we can write a surveys $year. For month we can write a surveys $month, and for days surveys $day, and the separator will be the same, will be a hyphen. But you see the option that this is also like prints a few of them, so you can see how it looks like. Have year, month, and day. So if but this is what we have here. We have the three columns pasted together, but we want the columns to be date rather than strings. So we would need to copy and paste that, and this will be the argument of the function YRD, year, month, day. If we execute that, we get now the date in format, in the format that is our date, but you see on the bottom you see an error that is 129 fail to parse. So let's see what is the problem with that. The problem with that is the following. Let me. That is a well. Okay. This output, we want to create a new column in our survey, so we can create a surveys $date assignation, and this column doesn't exist. But when we execute this, well, we get again this error. But we can use summary surveys, and you will see all the columns that were before, and also we see the date. We have a minimum date is 16 of January of 77, the maximum one 2002, the last day of the year, 31st of December. On NAs we have a 129. That is the ones that didn't parse. So the way to check what happened with that, we can find out the missing dates. So the missing dates, how to find them? We can select. If you remember yesterday, we can select a subset of the survey. So we need to use a square brackets. Let's specify here rows and columns. Oops, there is an M. So let's start with the columns. That is easier. So we want to get year. Oh well, we can. Let's do it. That will be more readable. Day, month, year. And for rows, which rows do we want? We want the rows that where survey date is NA. So we do is NA surveys date. So if we use that, we will get a vector that will be logical, true and false, and we will filter the rows that are survey state are NA. So if we execute that, well, we get here get here the first ones. Do you spot anything wrong here with the dates? Did you see why they were not parsed? This is the day, the month, and the year. So you could think that, okay, maybe the one of the entries were empty, but this is not the case. We have the day, we have the month, and we have the year. The no, that rather than the order exactly. The thing is, this is also one of the issues that you may find. That yeah, it's a little bit tricky to find, but yeah, exactly that the 31st doesn't exist in September, doesn't exist in April. So that's the thing, and that's why also we do this with R. We like we were talking the first day about the data cleaning. There are some dates that, for instance, here doesn't exist. So now you need to decide what to do with them. Can you can maybe modify them and say, okay, let's rather than 31st, let's write 30th, or you can even discard these entries. So this is depending on the research that you are doing, or the results that you want to get. You need to have a look at that and decide if you want to get modify the date, or rather than modify, maybe yeah, not use them, because in 35,000 entries, if 120 are not valid, you can. But well, this is not is a decision depending on what you are doing with the. Okay, so this is the last part of the. Well, this is regarding dates that we have seen that here we can create a new column and we can do. So the next part of the lesson, we will talk about we will use again the library that we have loaded before, tidyverse. So yeah, here we will use the library, and we will use okay, we have modified the plot. Well, sorry, the plot. We have modified the surveys. We have added a new column. We have used some factors. And what we will do is we will start, let's say, asking questions to the survey, or answering questions, because we have okay, how many like previously, how many rabbits do we have in surveys, the observation? So what is the average weight per animal? All of these questions we can solve them very easily. Using there are some libraries that are inside the tidyverse, because as I explained yesterday, tidyverse is a set of libraries. It's a library that contains several libraries, a little bit. And today we will use deploy, I think it's called, and tidyr. But well, because we have already loaded the tidyverse, you don't need it. So we will see these several new functions. Okay, what we will do is I will write data manipulation. That will be the next section. So the first function that we will learn will be select. And what I will do is I will copy this and we will go. So these are the functions that we will learn. This is already the documentation, so you don't need to. So we will start with the select. Select, where we will is choose different columns from the survey. So yesterday we learned that to choose, well, in the example we have, imagine that we're interested to choose a plot ID, species ID, and weight. So the way of doing that is leave the rows blank and select plot ID, species ID, and weight. So if we execute that, we get our data frame with plot ID, species ID, and weight. But we can do this in another way, that is using the function select. So we can do select. The first argument is always the data, so it will be a service data frame. And now we can write the name of the columns, plot ID, species ID, and weight. So if we execute that, we'll make this maybe a little bit smaller. Let me check if this is still. We execute select survey from service, select this, and you see that we have the same output. We have plot ID, species ID, and weight. This is regarding select. Select is to choose different columns. What I will do is maybe I will. Now we will learn how to use a filter. Because imagine that I'm interested in just one part of the service. Yesterday was one example that I'm, for instance, using, when we use a vector, I was interested only the vector that was called animals. I was interested in the number of occurrences that was with rat or what any other. So here, for instance, I can select only the occurrences that the year is 1995. So how can I do that? I can do that using the function filter. So the function filter is filter first the data, so it's a surveys, and now the condition. The condition is year must be equal. For equal, we need to write twice the symbol equal, otherwise will be a assignment 1995. So if we execute that, we can see here that we get. We'll make this a little bit bigger. We get a data frame that contains 1,180 rows and 14 columns. And here are all of the entries whose year are 1995. So this is a very similar. Tomorrow we will learn about SQL. You will find that these functions that we are using now and the commands that we will use tomorrow for SQL are pretty similar. So the idea is same. The first function select, we select the columns. The second one, we filter according to a criteria that we may have. Here we're using, well, there are two ways for, you can, the first parameter could be the data, but also you can use pipes. So imagine that you want to combine a filter and select. You can go step by step. You can select the surveys that are from the year 1995, and then you can, you can filter the entries who the year is 1995, and then select the number of rows. Select the columns that you want to plot. You can save this into several variables. We can do an example. For instance, I want to filter I want to get the animals whose weight is less than 5, and I want to select the species ID, sex, and weight. So if we want to do that without using pipes, we would need to do use variables to save the intermediate steps. So we'll need to do a filter, surveys, and the weight is smaller than 5, and then surveys small. We need to do a select from surveys 2 and the columns that we want, species ID, sex, weight. And now we print so here we select the first we have do a filter and then a selection. If you want to avoid this auxiliary variable, you can copy this here. But what is a better way or a more elegant way of doing that is using pipes. So using pipes is a pipe is like it goes from left to right, and you are doing applying functions in that order. So let me explain. We have surveys here. So this is the whole set, but we want to filter this set. So the way of writing a pipe is using a double percentage symbol and this one that is greater than. You can write manually write it, but also you can use Control Shift M in RStudio, and this is writing automatically. If you are using Mac, is Command Shift M. So now we want to filter. and say that the weight is less than 5. As you can see now, we don't need to specify the data because the data is sent using this pipe to filter. Now we need another pipe, so it was Control-Shift-M, and we will select the columns that we want to print. So it's species ID, sex, and weight. Oops. If we print that, you see that we have executed that, and we have the same data frame. So this is the way I have surveys, that is all the information. So I send this to this function. And at this point, I have a surveys filter by weight. So we send the output. So the output of this will be the input of select. That's why we don't specify data, because we send it in that way using a pipe. And also you can save pipes. You can do a surveys small designation, the arrow, and save that into this variable. To play with this, we have a challenge that I will copy in the here. So the challenge is using pipes, subset the service data to include the animals collected before 1995, and retain only the columns year, sex, and weight. So I give you a few minutes to do that. Please let me know when this is done, and I can continue with the. And also, again, if you have any questions, please feel free to ask. Okay, so I think we can solve this together. Today we will have more exercises like this, so we will spend more time with the exercises. Okay, the challenge is using pipes subset the service data. So we get surveys and we want to include animals collected before 1995. So we need to filter and set that the year is before would be like smaller than 1995. Pipe again and retain only the columns year, sex, and weight. So we do that, we select years, sorry, the name is year, sex, and weight. So if we execute that, we get the answer that we get we get the animals that were collected before 1995, and we retain only 3 columns: year, sex, and weight. So this is the answer of this challenge. Next function that we will learn mutate. That this is copy here. So it's create new columns by using information from other columns. So imagine that we want to, for some reason, we want to change. We have a column that is in for some reason is in centimeters and we want to modify it to meters, or we have a weight in grams and we want the weight in kilograms, we can create these columns for us. So the way of doing that, we will still keep using pipes. For instance, the weight, we know that the weight is in grams, so we will have it in kilograms. So we have surveys, pipe, that is this one, and the function mutate is we need to specify the new the name of the new column that will be weight kg, kilograms, that is equal our column weight divided by 1000. So if we execute that, well, we don't have here is not written the column, but okay, what we can do is we can use a pipe again and select weight and weight kilograms. Well, because all of them are well, a lot of weights are NA. As you see that here we have the weight that is 218 grams, and in kilograms is 0. So now we can use the new column weight in kilograms in order to play more with that. In the documentation they use so we can use this function head, but I think this is not a show because let me try again. Oh well, I can make this smaller. Okay, here we cannot see the weights because instead of this NA. We can using what we have learned before, we can use we can filter and get rid of the weights that are not that we don't know about them. So how we can do that? We can write a filter and we can say give me the ones that are not NA weight. Here don't forget the pipe, and if we execute this, okay, now it works. So now we have the weight here in this column and we have the weight in kilograms here. What we have done is we have get rid of the weights that are not that we don't know. We do the mutate function and we print the first 6 using the function head. So we have now a new challenge. I will copy this here. Well, also I will copy that in the challenge is in the chat of Blackboard Collaborate, and is create a new data frame from the service data that meets the following criteria. Contains only the species ID column and a new column called hint foot centimeters, containing the hint foot length that is currently in millimeters. And we need to get rid of the NAs and also the values that are less than 3. A hint here is you should be, you should pay attention to the order of the functions, because you can use filter, select in different order. And also another hint is that you can use functions several times. You using pipes, you can use the same function several times. Okay, so I will give you 5 minutes and we can see the answer. As before, please let me know when you have done the exercise and we can continue with the rest of the lesson. Okay, so I think we can solve this. Yeah, let's solve this together and let's see. The idea with this when this is like it's a complex exercise or you want something complex, to do it step by step, and you can see the results that you're obtaining. Okay, so I will do this. Okay, so let's do that. Let's do this step by step. So, well, first of all, we need the surveys on the pipe, and they said that we want a column called hint foot centimeters. Okay, so we need to use a mutate. Mutate. The column will be called hint foot cm. That will be equal to hint foot length is in millimeters, so centimeters. I guess that this is like divided by 10. Yes, divided by 10. So it must be okay. Pipe, and we want select this the okay the species ID and the new column. So it will be hint foot cm. Okay, so now we have a species ID and hint foot in centimeters. So we have part of the exercise. Okay, we want to get rid of the values that we don't know. So we do a filter and we get the ones that are not NA in the foot length on the pipe. Okay, so this is one step. And also, okay, we don't want NAs and our values must be less than 3. Okay, we need to get rid of NAs and values that are less than 3 centimeters. We can do the filtering here. That's the tricky part of the exercise. In this point, we don't know we don't have the column in centimeters. After this point, we have the column in centimeters, so we can apply again a filter, and we can say that hint foot centimeters. We will list that. No, sorry, the exercise is that we don't want NAs and we want values that are less than 3 centimeters. It's a little bit, I think it's quite tricky. So we apply that, don't forget the pipe, and we execute, and okay, I think this is the solution. We get the species ID here and the hint foot in centimeters, And as you can see, before was 3.2, 3.1, etc. And now values are less than 3. So this is the exercise. So I said you can use, for instance, a filter twice before and after input. Sorry, before and after the new column mutate, and also you can select the columns that you want. Not sure if there are any questions. If so, let me know. If not, we can continue. Next part is well, so that is like a paradigm that is split, apply, and combine. That this is in case we have the surveys, and we can do groups. We can get we can analyze some features of that group. For instance, for each sex, I would like to know the weight, the input, or I would like to know the weight. There could be the average, the minimum, the maximum. So this can be done using functions that we will learn now. Let me. So the functions are the following. Imagine that we want the average weight by sex. So we need to do this is a split apply combine. Okay, so here I write surveys, the pipe again, and first I use a group by because we want to group by sex, pipe again, and now I set what I want. If I want the maximum weight, the minimum input, whatever. So this is use, or we can use the function summarize. I think R, in R you can use either the British spelling with S or the American one with the Z. So you can choose the one that you prefer. We will here we are in teaching from Edinburgh, so let's choose the British one. Summarize. Now I will specify a new column that will be the mean weight. That the new column will be we will apply a function mean that is weight. As you remember from yesterday, we can get rid of the RM. We need to get rid of the RM. Otherwise, we will not get a good result. So if I execute that, I get the following table. Not sure if this is can make, maybe this is a little bit bigger. So we can have we can see that the average, the mean weight for a female is 42.2, and for male is 43. So to do that, we need to use this, let's say, this structure. First, group by the sex in our case, and summarize. And here we create a new column with the data that could be is the mean here, but we can use the maximum, minimum, etc. And also we can, okay, this is by sex, but what if we want by do groups by different columns? So it is possible to do so. We can group by sex and also by species ID, for instance. If I execute that, I get the average by sex and species ID. So female BA, the average weight is 9.16. Female DM. So you see, for each we have first a female, and we have all of the species IDs, and then I guess that I will have if we want to show the tail, we can do that right in another pipe, and we can use the function tail. Well, in tail we have the NA, that why in this case is not a number, because yeah, we don't have any. Also, there is another function in case that we want to print this function. We can choose the number of rows that we want to print. Imagine that we want to print, I don't know, 30. So here you see that we have a females and also we have a males here. So here we have not a number because I think maybe here we don't have a. I don't think that we may have entries for. Anyway, we can. We can also have a look and check if. Also, I can create. I have the average, but I can have a average on another column. So I can have, for instance, maximum weight. That will be the maximum of weight. So here for female, I have female BA. I have the average and the maximum weight. I get in here this error, but I think it's because I don't have entries. I can check. Sex is equal M and the species ID is equal AH. Is this because of the, or maybe, because I think maybe, okay, was yeah, the thing is I use M, I didn't use the quotation. So here I would like to check why I'm getting this, this is ID is equal, it was the one that was at AH. Yes, since that I cannot use more than one criteria, but it doesn't matter. We can use another filter. Okay. The error, I should read it tells me that there is an error in filter. We detect the name input. This usually means that you are using an assignation rather than double. Okay, so this was the error that. Okay, so that was the issue because it was an A. I mean, actually, I think I didn't have any. There are no. I think I can use count. Oh, yeah, maybe I think because the count is 0 for this. Let's see that over count 1. Anyway, so oops. So executing this, I get for each sex, I get the species ID. I can get the average and maximum weight. And also I can, if I want, I can sort the output with the function arrange. If I type arrange, I want to sort by the maximum, say maximum weight, for instance. Don't forget the pipe. We'll get rid of this. Yeah, I get this, but I don't like this. Okay, I think the way that they use what they do, that this is like maybe more makes more sense because this is like it's not so. First of all, it's done a filter, so we get rid of the values that are not specified. Okay, now makes sense. What we have done here is at the beginning we have applied the weight, so we get rid of the values that we don't know, they are not defined. And in this case, it's way easier to perform operations, and we will always get good values. We can, what we can do, what else we can do? Also, this is a sort by maximum weight, but we can do the other way around. We can do the sorted in a descending way. So if we do that, we get maximum weight sort by from maximum to minimum. Okay, so we are, well, last thing before the going to the break, but also we can use the function count. So we can do surveys. We can count the species by sex. So surveys, we do a group by sex count. So we execute that. I get the following table. That is, we have a more than 15,000 females, more than 17,000 male, and missing data undefined, we have almost 2,000. This is the way in case that, okay, you see that the column is end. There is another way to do the same. That is surveys, pipe, group by sex, and you can use summarize. I will use the English spelling, sorry, the American spelling to, you can see that it works same. And you can see that the column count will be function n. This is another way of, in case that you want to rename the column name. Okay, so this is what we will do after the break. We will have an exercise, and okay, what I will do, yeah, I will copy the exercise in the chat, and I will copy the exercise here. And but yeah, my advice is, yeah, have a break. We'll be back at 11:30, and after the break, we will do the exercise. So see you at 11:30. Bye for now. Welcome back. Hope you had a nice break. I will. So as I said before, we will have another exercise. Let me share the. So the exercise is written there. I will also paste that in the chat. So I will give you some minutes. Once that you are done with the exercise, please let me know. I would like to ask you. I'm not sure if you are interested in doing exercises or see more theory. I thought that, yeah, in order to like understand better uh, what this is about, I think it's a good idea to have some exercises. But please let me know if you prefer like have more theory, or yeah, let me know. Okay, so I think we can solve the exercises together if you don't mind. We can start with the first one. Okay, so the first one says how many animals were caught in each plot type survey. So, okay, so we need to do surveys, pipe, and this is a group by plot, must be. And I can use, for instance, I can use count. I can use also end, but I don't know. Let's see what is there. Oops, I don't know what I have done. Okay, yeah, I think I know. I press Control Shift Enter. That means that I executed uh, the whole file. That's why it was this getting crazy. But okay, so let's use now Control Enter. Okay, the error here, they said that the column plot is not found because maybe it's a plot ID. Okay, it's plot ID. Also, that's the thing when you have an error, don't panic. Don't say, "Oh, R is not bad at giving error messages." So sometimes when you read the error message, you can get a hint of what it's failing. In this case, it's clear that they said the column plot is not found. So it's a problem with the name of the column. Let's execute this again. Okay, so yeah, I think this is what the exercise wants. So we have plot ID and we have the number and the column here. Okay, done. Second exercise, use group by and summarize to find the mean, minimum, and maximum input length for each species using a species ID and the number of observations. So we can reuse this. Well, let's start from the beginning. Surveys, because we will do calculations. I want to get rid of the input values that are not known. So we will do a filter. Is dot na input length pipe group by species ID and summarize. So now I need the mean food that is equal a mean input length. We want the mean, the maximum, and the minimum. So maximum, oops, and minimum. Group by summarize to mean maximum minimum for this species ID. Okay, so okay, let's see how it looks like. Well, what we can do is let's do a select species ID, mean, max input. Okay, because I think there is a there is a extra comma here in the. Thanks. Okay, 3 answers rather than 2. Yeah, that's too much. We have only 2. Thanks. Okay, so yeah, that's the yeah. Okay, so this is part of the exercise. We have a mean, maximum, minimum. but we missed also they want the count. So the count, well, we can add the count at the beginning. That will be count equal n. Well, also I need to select here, otherwise it will not appear. Okay, so this is what we have. We have a species ID, count, and we have the mean, maximum, and minimum. So this is the exercise. Okay, the third one, a little bit more tricky, but this is what was the heaviest animal measured in each year. Return the columns year, genus, species ID, and weight. So let's go step by step. We write surveys, the pipe, each year. So I think we need to group by year. Group by year. Oops. Pipe. And also we are talking about the weight. So again, I will filter because yeah, want to get rid of the NA values of a weight. Group by year, and these are the heaviest animal measured in each year. So it's okay. What I will do is well, select the columns year, genus, species ID, and weight. Let's see if that what is the result that we get. So we get here year, genus, species ID, and weight. That is it what they want. And we get for 1978, we get the genus, species ID, and the weight. But this is not, I think this is not what we want. We have done group by year. Okay, the away, this is why it's more. Okay, so the thing is, that's the idea, like go step by step. So this is what we have here, but what we want is the maximum weight for each. So maximum weight, we need to do another. We need to do another filtering. Yes, one way could be like add a new column, max weight, and then filter by that column. But another way could be after group by. This is important. The group by year filter weight equal maximum weight. Don't forget pipe here. So let's see what is the again. I need to use double rather than. So here now I get the maximum weight. So you see that first I do I get rid of the NAs here, group by year, and after that I do a filter, weight equal max weight. And also what I can do to make this, I can sort by year. And also I would like to print everything. So print and equal, I think we have here 26, so I will print the 26. 27. Okay, so I have I think I can make this bigger. So this is what I have executed. And I get sort by year, genus, species ID, and the weight. This is one way of doing that. Another way could be like creating a table. Well, you can create also, but will be longer. You can create a new column with the max weight, and also do later the filtering. But this is a way of like skipping that step. Yeah, this is like a little bit complex or a little bit, but well, in you may find that you need to know that. So this is the way of solving it. And that's the good thing that we are using a data set. Well, this one is a small one, is a few megabytes. But imagine that you have a larger one. So with a few commands, you can get the answers that you are looking for regarding the data set. Not sure if there are any questions, let me know. If not, what I will do is I will explain what I said. I think what we can. Okay, the last part of data manipulation is that we can create, we can change the shape of a table. So we have a during this course, we have learned that we want have columns. Each column is a variable, and each row is an observation of that. So we may want to change the shape of a table. I think to explain better is if what I will do is I will share the documentation in the screen, and we can do a small example. Let me share this. So what we want is we have an ID, we have a key, we have a value, and what we want is reshape the table. Here looks like maybe it's not the best, but here we have an example that you can see. We have a we choose only 3 columns. So we have a plot ID, we have a genus, and we have the average weight. But imagine that I want to group, or I want to like have the genus has columns, and the mean weight as the values of this. So what I can do is I can group by plot ID. So you see that the transformation is from left to right. So I get the plot ID because we have only 3 plots. So I get a plot ID, I get 1, 2, and 3. We have names from, so for genus we have this we choose the distinct values, and I have them as column names here, and the values that appears in this column, mean weight, will be here. So this is could be the case that you need to do that. So you can do that using there are two functions that are called pivot longer and pivot wider. So the thing is here we have a, let's see, a longer table, and we want to make it wider. So we use pivot wider. I understand that, yeah, sorry, the beginning a little bit difficult to understand, because this is actually, yeah, quite new. So we have a data frame where this is the line. We have a data frame here with a pipe. We use pivot wider. We need to specify names from the genus column. We need to specify the names and values, the names of the new columns and the values of. Genus will be the where we will get the names, and the values we will get them from mean weight. What I can do is I can do this example on R Studio. So I will share now. I think it's this one. Yeah, this window. So let's do that. The thing is here. I need to create a new this is using a smaller table. So this table in the documentation is called surveys underscore GW, and we save here the output of surveys pipe. We will get rid of the weights that are not known. Is.na weight. Yeah, this is not. Sorry for the typo. Group by plot ID and genus pipe, and summarize the mean weight is equal a mean weight. So I can have something like that, and if I print surveys GW, I will get a table similar to the one that is shown in the documentation. Plot ID, genus, and mean weight. So what I want is I want another shape. I wanted to have a genus as columns, and the mean weight will be the content of the table. So the way of doing that, I can create surveys wide assignation. That will be the surveys GW pipe. And here I use pivot wider. We have a longer if we want to do the opposite, but here we will use wider. We need to specify where we will take the names of the columns. So the names of the columns will come from genus, and values will come from mean weight. Let's see if this is what we want. So if now I print surveys wide with control, I get something like that. I get for each plot ID, so we have from 1 to 10, I get the average weight for each pieces. You see that the table is we have 20, how many? Okay, let me see the structure of surveys wide. Okay, so we have a time plot, or well, I think it's we can do a summary. Maybe yeah, it's easier. Ah no, okay, okay, we have 24 rows, and the columns we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 9 different species, and we have 24 plots. Yeah, okay, so Saturday, yeah, it's 24 rows and 11 columns. So we can get something like that. From we got the transformation from here to here. Also, we can do the other way around. That will be the syntax is quite similar. Is rather than pivot wider, is a pivot longer, and instead of names from is names to, instead of values from is values to. Well, what it changed that you need to also select the. Let me show you the. Oops. A moment that they share this. Share. No. So the other way around is something like this. So loading. Okay. So imagine that we have this table, and if we want to go to have a, let's say, longer one, we do we get the values of the table are only in one column, so this is values 2. The names of the columns goes to are a new column called genus. And the thing here, what it changed that we need to specify the column that we will let's say we will keep. That will be plot ID. So we will perform all the operation with all the columns except plot ID. So you can do a transformation from wide to long. Yeah, this is a little bit complex and you may not need that, but it's good to know that this exists in case that in the future, working with R and working with data, you needed that function. So what else we need to, let me share again. RStudio allowed. Because the next part of this today's lesson will be creating some plots. We will before that we would like to clean the data set in order to print to make things easier. So because we have the original data set, you have seen that we have the weight that contains a lot of unknown values. Hint foot is also contains unknown values, so we want to get rid of that and save them in a new file. So to do that, we will create a new, we will call it export data. So what I will do is I will create a new variable called surveys complete, that this will contain the surveys pipe, and I will filter I will get rid of the weights that are not are empty or not known. I will get rid of the hint foot length, that is empty, and also if sex is not defined, oops, it's an A, I will get rid of that as well. Now if I execute surveys complete, you will see that the number of rows is smaller, but either weight, hint foot, and sex will be defined for all these entries. So this is what I want to. Also in the documentation appears we can keep this table, but imagine that we don't species that appears less than 50 times. We want to get rid of them. So to do that, we need to do a. We will need to filter them according to the count. So to do that, the way of we can create a new variable called species count, where we will save surveys complete, where we will use a surveys complete pipe. We will count the species ID, and we will filter those whose n is, or we will keep the ones that are larger and equal to 50. So if we execute that, and now we print species count, Here we have a species ID and N. And we see that we have rather than 26, we have 14. If we print only that, in case that we want to go step by step, you see that rather than 12, I have 24, and I have, for instance, this one is 5. So we will get rid of this one. And the way of doing that is combining species surveys complete and species count. So we will update surveys base complete using surveys complete pipe. So the pipe is, yeah, this one. And now we will we will learn a new way of filtering this. So we will filter the species ID that are in. This is a new so between percentage symbols are in, and we get the column species ID. Sorry, we get from species count, that is a data frame, we get the column species ID. So here we can, in other cases, we can have a vector, but also we have this column. So if I updated that, and now I print again, surveys complete. You see that before the count was 30,676, and now it's 30,463. The difference is small because we have removed the species that doesn't appear quite a lot. So once that we are happy with that, we can save that in a file. So before we have used read CSV, so now we will use write CSV. What we want to save, so we will save surveys complete. Also, you can save if you have smaller tables or smaller data frames, you can save them. So here you specify the data frame that you want to save. And now you need to specify the path. The path will be file and will be data. Remember that the files that we have, the structure, we have data row and fig. So we will save that in the folder data / surveys complete .csv. If we execute that, and now if we go to data, we will see that I have a new file called surveys complete, slightly smaller, it's 2.4 megabytes. If we go to the original one is 3 megabytes. We see that the file has been created today. So this is the file that we will use to print to do some plotting. Not sure if there are any questions so far, but if not, we can continue with the plotting. Before starting with plotting, what I would like to explain or give a heads up is you can do many plots with once that you have the data set that you want to do some plotting. That could be for a conference, a paper, for a blog post. You have many options. So you can create a pie chart. You can create a box plot. You can use. You have many. So here, what we will run is the basic plot that we can do, a very small part, but the thing is that you can modify colors, you can modify shapes, you can do many things. So here we will see just a small example of what we can do, and with that you can always build up and choose the legend, choose the label for the x-axis, the y-axis, so on. To use the function that we will use to print is called Ggplot. Okay, I will create here plotting. So we will use Ggplot, and in Ggplot you need to specify, for instance, if you want well, the plot, you need to specify what will appear on the x-axis and in the y-axis. So the way of doing that, let's start with the where the syntax is. I will write this like as a documentation. Is a ggplot, and you need to specify data mapping, and then with a plus symbol, you need to specify the what you want to use for plotting. If you want to use a point, square, cycle, or anything that well, point and cycle is the same, but the geometry that you want to use. Okay, let's do an sample. The sample is ggplot. Data that I will use is the one that comes from surveys complete. And now I need to specify what will be in the x-axis and in the y-axis. So I use the function as, and here for x I will specify weight, and y I will specify a hint foot length. Again, is a th. And I will use a point to do that. So if I execute this, let me make this maybe a little. You see the here on the right bottom right, you will see the plot that I have. So I have the for each this is a scatter plot for each observation. I have for instance this point is the weight would be 40 and the hint width length would be 3, let's say. So each observation has a point here, and you can create a plot something like similar to this. Things that I can modify. I think if you go to the help here and go geom point, you will find parameters that you can have, that there are many, but here we will see only a few. That one that is interesting, for instance, because you see that in this area, or this area is quite difficult to see, well, because there are many points over there. You can specify a transparency with the parameter alpha equals 0.1. Did you execute that? Yeah, it takes some time because it's a big data, but well, now this is done. And you see that the points have a transparency of 0.1. So you may like this graph better than. Also, you can, if you don't want to, like, you want to print this in blue rather than in black, you can choose the color blue. Okay, blue should be a string. So but the thing here that we get weight and the input length for all species. So that, I don't know, maybe okay. This is helpful to know have the whole picture of the data set. But what if I want to get a color depending on the species ID? So this is possible. I can remove color, and I can use the function as and say color equal species ID. If I execute that, take some time to calculate this. Now we see, okay, let's make this okay, not showing the okay, because this is okay, now it's better. There was a lot of zoom. Okay, now it's you can see here colors. The okay, maybe the alpha is a little bit. Let's make this a little bit more 0.3 maybe. Try 0.2. I think it's yeah. I have a for each species ID. I have a color, and we can see the mapping of this. So we see. I think this is NL. So here, yeah, it's a little bit because there are many colors and maybe it's not a very bad. You can see a better mapping of a species ID, the comparison of a weight and the input length. So this is one plot that we can do. Another one is we can use a box plot to see the distribution of weight within each species, for instance. So the way of doing that is the following. We use Ggplot Again, data will be equal to a surveys complete. And the mapping will be, again, we use the function as that we need to specify the x and y. X will be species ID, and y would be the weight. And rather than printing a point, what I will use a box plot. So if I execute that, I get the following. I get the species ID on the x-axis, and the weight is here. So having a box plot, I can get the distribution that for DS, for instance, can get in the this will be the maximum, that is close to 200, the minimum close to 0. Okay, this is the average, is 125. So I guess that this is the 50% of the. So here you can have all the weights in a box plot. Also, if you want to, again, you can use a different. Because these are the weights, but imagine that in the same plot, you want to print something else. You want to print the number of the number of measurements. So you can do this like this max, and you can do geom jitter. Can specify the alpha. We will use an alpha 0.1, for instance, and the color we will use green, for instance. Let's see how it looks like. So here, yeah, maybe this is not the like a best, but here you see the for each species ID all the measurements that we had. So for instance, you see that SH is we have a small quantity or more scattered than PF, for instance, that is all measurements are a very similar value. So you can have many ways of. Also, we have seen a box plot, but we can do. I think there is another one that is called violin. So rather than a box plot, you can get the violin. So maybe if we make this something like that, but well, it will have a same. So you can get things like that. Yeah, the violin doesn't look like a quite. So let's do again box plot. The thing with this this part is to to learn that we can do many things. So the most important thing is we are using Ggplot. We specify data here, and also we specify the mapping. That we use the function as, and we specify what appears in the x-axis and in the y-axis. Let me check if there is a question. I think, okay, there is a comment that the mapping doesn't appear in the first, when we use first time. I think if we use, because the second parameter of Ggplot is mapping, so there is no need to specify that. If, yeah, I think this is something that is in the, if we go to the help of a Ggplot, you see that the first parameter is the data and the second parameter is mapping. So if you follow the order, you don't need to write either data or map. You can write this to make things more clear, but also, for instance, we can get rid of, if we go to the first one, also we can get rid of the map, sorry, of data. So we can use a ggplot service complete, and as only we execute that, we can get the same. So yeah, that was yeah, no, but you are right. Yeah, it's a little bit confusing that sometimes it's defined or not. This is more for readability purposes. There is a small exercise that, well, what we can do, I think maybe I can give the exercise as a homework, and we can finish this part in order not to finish too late today. Okay, the next part is because we have seen here that we use the same plot for all species ID. But what if I want to get separated by species ID of, well, the sample that I have here is by genus. We can use what is called faceting. So we can create several subplots inside the same plot. How we can do that? Let's write here comment faceting. The way is ggplot. First the data. So I will let me. Okay, that is something that is not defined on the. Okay, so let's do this. Imagine that, okay, I have a survey complete and I want to print the number of counts by year. So for that, I need to create a new. Data frame. The data frame we will call yearly count, that will have we will use a surveys complete pipe, and this is pretty easy. We will just store the count of year and genus. Count year, genus. So if we execute that, and now we want to print a yearly count, you see that we have for each year, we have the genus and the count here. So as you can see now with this table, we can create a plot. We can use a very simple one. So we can use a Ggplot. Remember, first thing is the data. So we can do a yearly count. And the second thing is to specify with eyes the X and Y. X will be the year, and Y will be the N. You may notice that here I'm not specifying X, Y, and also I'm not specifying mapping. So that's the thing here. There are two ways of writing. You can do something like that. So it depends. Let's say this is the complete version, and this is the short version. That is, depending on the content, you want to make this more readable, and you can specify the argument names. But in case not, you can write something like that. This is up to you. These are the two versions. I will copy this and comment. Okay, so now because what I want to do is I want to print this as a line. So there will be a line. Let's see how it looks like. So we get the count on the y-axis and the year on the x-axis. But the thing is that we get the count for all of these, for all of the genus. In case that we want to split by genus, I need to specify in AS, I need to specify the group, like I do a group by, that will be a genus. I will add this for clarity, group. So now I get for each genus, I get a line. The problem is that all lines are the same color, so it's a little bit useless. So if we specify rather than group, if we specify the color genus, okay, that looks better. So here what we have is the number of, we see that at the end of the year, well, the latest years, we have a more count of Todipus. And for instance, the Dipodomis, we have the most of the accounts. We see that the pink one, that is Sigmodon, we have a very small number of counts, not to say zero. So this is the thing that we have in the documentation. You will also find that there is another way. Rather than specifying the data here, you can get rid of that and use a pipe. So you can do a yearly count. And send that to a Ggplot. When you print that, you will get the same. So okay, this is all genus are in the same plot, but what if because for instance we may want to have this separately in the uh, different subplots. So this is what is called faceting. So what we will do is we will copy and paste that. Now we will not group by genus. And what I do is I will add a facet wrap, and the facets will be equal bars genus. The thing is, I'm explaining now in this part a lot of things that you will always have the documentation. So normally when you do some plotting, first you check the documentation, you do a basic version of your plot, and then you, okay, I want to modify the color, or I would like to do this. So you need to always check the documentation. You will not always remember all of this. Here I like explaining all of the different possibilities that you have, but you don't need to remember all the details or all the commands. That's why we have a documentation. What you need to know is that that exists, that you can do as many things as you want. There are many possibilities doing. Okay, so let's see if that works. And now, rather than getting one plot with everything, we get for each genus, we get the counts. So this is another way that we want to. Also, uh, also another example. This is having like males, females. What if we want this split by sex? I can add color equal sex here. And it complains. Maybe because I didn't specify. Well, okay, statement. Ah, no, okay, because this is okay. This is using another. The complaint is because in the we need to we are using a yearly count. Let me plot. We have a year, genus, and n. We don't have a sex. So if we want that, we will need to write yearly counts sex. That will be surveys complete pipe and count. Oops, count. We have a was year, genus, and also we can add a sex. So if we print yearly count sex, our is count. We have this according to year, genus, and sex. So if we repeat this, and now I add color sex. Also need to change I can do something like that. Now you see that I can, because I have this table with year, genus, sex, and the count, I can print according to sex. So that's the thing that you can do. You have the whole data set, you do some filtering and get a smaller data set, and then you can print the data set and you can play. This is a very good, like, okay, I will check by sex, or I will check by year, or I will. You can play a lot with the things that you plot, and also you can change the because we are using BRAP, but also you can change the format of the yeah, there are many options. You can use rather than facet BRAP, you can use facet grid. What that means, that you can specify the rows that are equal bars sex, and you can specify the columns that are equal the bars of genus. So now if you execute that, okay, it doesn't look quite, maybe you need to zoom, but you see that, okay, maybe if we make this, okay, it's the sum of this. So you see now the variable, we have for each, we have a split by sex and by genus. And you have here the years. The thing is, yeah, we need to work better with the, we make this bigger, because you see that the years are like at the bottom quite smaller. Oops, let me make this a little bit bigger. So there are many options that we can use with the grid. We can have a, okay, we see that here this one maybe is not the best one, so we can do something like this, have this in rows. So doesn't look quite, maybe if we make this bigger. So yeah, we can play a lot with the, maybe rather than rows, can use columns. But okay, I think I like more this this one here. Yeah, this looks better. Okay, so I like this one. Last thing that we will see is to save the plot, and the thing is one thing that we can do, or well, we haven't before finishing, is to make this maybe to do some modification. For instance, we can change this level, we can change this one. So the how we can do that? We can use the new thing that is called, we can add labels. So we can use this function, and we can use we can define the title, that this is can use observer genera do time. We can specify x, that is year, and y, that will be count, for instance. Okay, this is the one that I don't like. I like this one. So you see now we have modified the labels here. Also, we can this is all in the documentation. We can edit the font to make this bigger, to change the we can choose the font size. We can do also we can rotate these numbers and put them vertical. You can do many things, but what my advice is to know that this could be possible, and check the documentation and do all of these modifications. That you can also change the color. You can do whatever you want. Once that you are happy with the plot, you need to save it. So you can use. Okay, I don't like this one, so I will get rid of this. You can save it in my plot assignment. So now I have a new variable called my plot, and what I specify here is I use the function ggsave. The name of the file, that will be I'm not very original, or fig1.png. I recommend you use a better name, but well, that's for example. The plot that I want to save, so I will save my plot. And now I can specify the width, that will be 50, and the height, that will be 10, for instance. I want to save that in my folder called fig, so don't forget about that. So if I execute that and I go to files, data carpentry, fig, you will find that you have a new file called fig1.png. I click on that, but you don't see because it's open on my screen. But what I can do is I can fig1.png. So you click and you have that save as a figure, and you can use that figure in your paper. So sorry, this part has been like a little bit rusty, because the thing is that with the plotting you can do many things, and you can spend several days talking about all the possibilities that you have. But what I want is to explain and to let you know everything what is available, and checking the documentation. I think you can do that by yourselves. 1 p.m. So like end of today's lesson. In case that you have any questions, let me know. You can send me a message this afternoon. If not, we can meet tomorrow at 9:30. And we will learn more about SQL. Thanks for attending today, and have a nice rest of the day, and see you virtually tomorrow. Bye for now.